subject of mechanical system design. I am Professor A.P. Godke. Today we are discussing about the design of pressure vessel using a suitable software like AutoCAD or ProE or CATIA. So how the unfired pressure vessel is designed and how the different components are going to design and how that components are going to assemble, that we are discussing this topic. So this part is included in theory also for as unit number 4, design of cylinder and pressure vessel. So we will see what are the different components that are present in the pressure vessel which are going to design. So first important component is upper shell. So we are basically design the vertical pressure vessel. So there are two types of shells are there in the pressure vessel. First one is the upper shell and second one is a lower shell. So here you can observe the front view of the upper shell. The dimensions are there, which is that is height is 800 mm or meter, you can say, and 40 is the somewhat base or flange is there at the head. Then this is the top view of upper shell. The material used for this upper shell design is alloy steel. Then here different types of nut bolt arrangement is also there. So you can see here M20 by 2 number of 36 with the piece circle diameter as a 917 is used. The scale for this design is considered as a 1:10. Then the quantity of upper shell is 1. So this is the first component that we are going to design using a CAD software, that is upper shell. Second one is a lower shell. Again the dimensions are given as a lower shell. Then the hole for the pressure gauge connection is also provided. So it will measure the pressure present inside the shell. So this is the lower part of the lower shell of the vertical pressure vessel. Then the material is same as that of upper shell, that is nothing but alloy steel, and the quantity is used as a 1. Then same type of nut bolt arrangement is there. Number of bolts and piece circle diameter is 917. It's common for lower shell and upper shell. Then third one is upper TORISPHERICAL head. So this is the diagrammatic representation of the upper TORISPHERICAL head. So this is the third important part of the TORISPHERICAL head. So the material used for the TORISPHERICAL head is alloy steel. Then here you can observe the upper head safety valve or pressure relief valve is provided, hole for the safety valve. So here we can provide the safety valve. Then these are the dimensions are there for the upper TORISPHERICAL head. Means this head is situated or located on the upper side of the upper shell. So this is the scale used is 1:8 for this component. So this is the third one. Fourth one is a lower TORISPHERICAL head. It will be located at the bottom side of the lower shell. So again these are the dimensions used for designing the lower TORISPHERICAL head. Then the material used is alloy steel, which is common for the upper shell, lower shell and upper TORISPHERICAL head. Then the quantity is used again 1. Next one is inlet and outlet nozzle. So these are the diagrammatic representation of inlet and outlet nozzle. So here the important conditions for the inlet boundary condition or the dimensions for the inlet nozzle and outlet nozzle. The material used again for nozzle is alloy steel. Quantity is 1:1. So two types of nozzles are there. One is the inlet nozzle with these parameter DN, DNC, TR, thicknesses, diameters are there, height is there, pressure is also there. Then inside diameter, outside diameter is there, clearance is also there. So these are the standard values that are used for the designing of the inlet nozzle and outlet nozzle. Then flanges at inlet for the nozzle, the flange which is made up of a cast iron. Then these are the dimensions of the flanges. M6/1 are the nut bolt arrangements are there, number of are there 8, and piece circle diameter is 160. Then scale is 1:2 and the material used for the flange is the cast iron. The quantity is nothing but one quantity flange is at inlet is used. Second one is a flange at outlet. Again, the dimensions are there. Then an M6 by 1, a number of bolts are there for 4 and piece circle diameter 1 is to 15. So this is the one of the flange which is used as outlet, and quantity is 1, and the material for flange at outlet is a cast iron. The next one is a gasket which avoids the leakage or provide the provision for avoiding the leakage of the pressure vessel. So at inlet, the gasket at inlet flange is used. So these are the dimensions. So then the material for the gasket is asbestos and quantity is 1. So this is the again spherical shape gasket is there, or circular shape gasket is there. Next one is a gasket as outlet. So these are the dimensions of the gaskets used as outlet. Then the material is again asbestos for gasket at outlet flange, and the quantity used is 1. Next one is a gasket used at manhole. Is again these are the dimensions for the gasket which is used as the manhole. Then the asbestos is the material for again gasket, and the quantity of gasket used for the manhole is 1. Then next one is a vertical skirt support. The two supports are used for the pressure vessel which are connected to the lower shell. So the vertical skirt support is used, the material for vertical skirt support is cast iron, and the quantity of skirt support is 1, and these are the dimensions for the skirt support. Then the angle and the title of the sheets. Here you can see that the title is the design of unfired pressure vessel. Then a scale used is a 1:1 for the sheet. So these are the nothing but angle and title sheet for while drawing of the sheet. Then the college name is there. Then the title of the sheet is there, and the angle method used for the design of the sheet. Next one is the assembly of the pressure vessel. So you can observe this is the assembly of the pressure vessel. So here you can observe the different components. So this is called as upper shell, this is the lower shell. Somewhere here manhole is provided. Then this is the opening at the lower shell. Then this is a lower TORISPHERICAL head, this is upper TORISPHERICAL head. This is the outlet, inlet outlet for the pressure vessel. So hole for the safety valve is also there. So this then hole for the pressure gauge, here hole is provided for the pressure gauge. So this is the overall assembly of the vertical pressure vessel. So here this is nothing but skirt support is provided for the pressure vessel. Then a sectional view is again sectional view of the pressure vessel. So you can observe here this is the vertical pressure not vertical, this is the vertical pressure vessel, in that this is the upper shell, and this is the lower shell. Then this is the upper TORISPHERICAL head, this is the lower TORISPHERICAL head. Then these are the outlet nozzles are provided. Then this is the provision of the pressure gauge. Then a provision for the safety valve here. Then here it is joined for upper shell and lower shell. Then these are the supports provided. Skirt support is provided for the vertical pressure vessel. Then this is the orthographic view of the pressure vessel. On the you can see the orthographic view of the vertical pressure vessel, not horizontal. Then this is the 3D view of the pressure vessel. So you can observe this is the 3-dimensional view of the pressure vessel. So here pressure gauge can be mount, and which can measure the pressure of our pressure vessel. Then here safety valve is provided, so to avoid or to release the pressure inside the excess pressure inside the pressure vessel. Then this is a upper shell and this is lower shell. Then using the nut and bolt, here is the joint of the upper shell and lower shell. Then here it is a skirt support, and here somewhere manhole is provided for the maintenance purpose also. So the entire material for the pressure vessel as already alloy steel we are going to use. Then this is the outlet of the pressure vessel. So upper TORISPHERICAL head is there, and lower TORISPHERICAL head is also provided. So this is the 3-dimensional view of the vertical pressure vessel. Then the bill of material. So here you can see the what types of components materials are used. So first one is upper pressure, upper vessel shell is the quantity is 1 and alloy steel is the material. Then the lower vessel shell, then lower vessel shell, the alloy steel is the material. Then upper TORISPHERICAL head, the alloy steel is the material and quantity is 1. Then the lower TORISPHERICAL head, alloy steel is the material and quantity is 1. Then inlet and outlet nozzles are there, the quantity is 1. Then inlet and outlet flanges are there, the cast iron is the material and quantity is 1. Then gaskets are there at inlet flange, at outlet flange and at manhole. The material is asbestos and quantity is 1. Then vertical skirt support is used, the one is the quantity and cast iron is the material. Then different types of bolts are there, which are made up of a plain carbon steel. So number of bolts are given and nuts are given. So the plain carbon steel is the material for the nuts. So number of nuts are provided here. So total are 36 plus 4 plus 8 and here 36 plus 12. So total nut and bolts are going to match. So this is the bill of material. Then finally title of the sheet. So here it is the title, design of unfired pressure vessel. Then drawing title is the assembly of unfired pressure vessel, and second sheet is detail of the unfired pressure vessel. So thank you for watching the topic design of pressure vessel. So this design of a vertical pressure vessel is completed by using AutoCAD software. So thank you for watching the video.